24/7 services under all weather conditions. The Navik has immense use for fishermen going to sea. It helps them to reach the high-yielding locations, alerts them about bad weather and international water boundaries. Apart from fishermen, Navik helps the merchant ship to their destination in the ocean routes, aids them to search and rescue in disastrous situations. Navik supports numerous applications in the road and railway services. It helps in navigation from point A to point B, tracking of passenger vehicles like trains, buses, taxis, tracking of school vans and traffic management. The position information derived from Navik helps the entrepreneurs and government agencies to manage the resources efficiently using geotagging and geofencing techniques. Position information from Navik with geoinformatics systems. A host of location-based services are offered to general public, be it locating a restaurant, shop, office, fuel pump, picnic spot, etc. Using multi-constellation precision agriculture, road and railway alignments, etc. Navik is also useful in efficient telecom operations, power grid operations, disaster management, atmospheric studies, etc. Thus, Navik plays an important role in every aspect of our life. The satellite has been realized with the team effort of ISRO. Space Applications Center, Ahmedabad, was responsible for realizing the payloads. All sensor elements were delivered by LEOs, while IISU provided inertial elements. LPSC delivered propellant and propulsion system components. Vikram Sarabhai Space Center, located at Thiruvananthapuram, supplied all the composite elements like antenna, yokes and substrates for solar panels and pyros. The ISRO Satellite Center, ISAC, at Bengaluru was responsible for the bus systems. The satellite assembly, integration and the environmental tests were carried out at ISAC. The ISRO Navigation Center, located at Bayalalu, is the heart of the ground segment of the Navik. The Navigation Control Center at ISTRAC, Bengaluru, and the Satellite Control Facility at MCF, Hassan, play an important role in continuous monitoring and control of space segment. Navik ground segment is operational 24/7. It has a number of Indian range and integrity stations. All typically spread across the country. Segment IRNSS CDMA ranging stations, IRNSS network timing centers, ISRO navigation centers, and control facilities. Sufficient redundancies are interconnected. Data communication. Coming back to IRNSS 1H, after many stringent tests, the satellite is now integrated with the Satellite Launch Vehicle PSLV-C39 at India. ISRO navigation centers and control facilities. Sufficient redundancies are interconnected. Data communication. Coming back to IRNSS 1H, after many stringent tests, the satellite is now integrated with the Satellite Launch Vehicle PSLV-C39 at India. Roger.
is ready for PSLV-C39.
And so welcome back to the live events from the Mission Control Center.
Mission Director Roger.
We are at less than 17 minutes to 40 seconds. We just heard the announcement of Vehicle Director giving authorization to the Mission Director. So giving authorization to the Mission Director. So first stage assembly is in progress. The last head segment and first stage is ready now, is 139, and to this now we will have the assembly of the 6 solid strap-on boosters and the propellant loading of each of the strap-on boosters is 12 tons. This is the strap-on booster being moved from the facility in Shah to the launch pad, the second launch pad. So integration of the solid strap-on booster, which is
Mark minus 12 minutes uncounting. Automatic launch station for PSLV-C39. IRNSS 1H mission is initiated.
We just heard the announcement. Minus 12 minutes, ALS has been engaged and the vehicle is going through the checkout of the various second launch pad. So now the first and second stages of the vehicle are fully assembled. This is the third stage, which is a solid stage called S7, which has a propellant loading of around 7 tons. And what is being lowered now is the fourth stage, which is a liquid stage. So it's a third and fourth stage called as PS3 and PS4 is an integrated module. And this integrated module from the preparation facility is being moved to the launch pad. And as a single module, it will be mated to the second stage of the launcher. So once this assembly is completed, the launch vehicle is ready to receive the satellite as all the 4 stages of the rocket have been mated. This is the view of the IRNSS 1H in the satellite preparation facility at the launch base. And the spacecraft going through the fueling operations, and after the fueling operation, it's assembled at the launch pad. And once the vehicle is fully assembled and checked out, the vehicle gets moved from the vehicle assembly building on a mobile launch pedestal. As a view of the PSLV-XL vehicle moving on the mobile launch pedestal and being brought to the umbilical tower, which is the launch pad.
Minus 10 minutes and counting.
So PSLV-C39 umbilical tower. So countdown is at minus 9 minutes 50 seconds. View of the mission control center. Chairman is Shri Kiran Kumar ji, Mr. Punnikrishnan, who is the Director of the Satellite Space Center. So here the mission control.
So hello everyone, first test, can you hear me?
Closely monitoring the process of automatic launch sequence when the vehicle parameters are getting checked out. So we are at minus 9 minutes 20 seconds for the launch. जहाँ तक मौसम का सवाल है, कल और आज सुबह से काफी साफ वातावरण दिखाई दे रहा था और लॉन्च के लिए के समय बिल्कुल अनुकूल. So minus 9 minutes. आप एक नजर आज के PSLV PSLV-XL लॉन्चर, ये 4 चरणों वाला रॉकेट.
Event number 563. Data nuggets are on in Sharman and Sharp 2 stations.
और लॉन्च के समय 320 टन वजन वाला रॉकेट है. इसका पहला चरण जो सॉलिड ईंधन का है, उसे सॉलिड कोर बूस्टर S139 स्टेज कहा जाता है और ये लगभग 139 टन का ईंधन ले जाता है और इसकी ऊंचाई करीब 20 मीटर की.
So hello everyone, today we are going to watch the launch of the Indian IRNSS 1H navigation satellite. The satellite is part of a constellation, the 8th part of the constellation, to provide navigation like coverage over India. It basically works like GPS but in a separate system. The rocket is a PSLV-XL, which means that it has 6 large solid rocket boosters that really carry most of the weight during liftoff. And of course it is going into a polar orbit as the polar satellite launch vehicle usually does, and as is relatively useful for this sort of navigation constellation. The launch, as you can see in the upper left corner, is scheduled in about 7.5 minutes, as you just could see in the upper half corner. Now, there is a slight echo in the stream that is actually from the source and not from me.
उसके बाद 14 मिनट पर ऑटोमेटिक लॉन्च सीक्वेंस को ऑथराइज कर दिया था और लॉन्च के पहले ऑटोमेटिक लॉन्च सीक्वेंस इनिशिएट हो गया है. एंड इस लॉन्च को ऑथराइज करने वाली जो body है,
you can also hear the audio properties are slightly different. They're probably recording sound directly from the announcer and also recording sound from the Space Center, and the announcer is also broadcasting into the Space Center, so they're basically recording the announcer twice.
So minus 6 minutes 40 seconds for the countdown.
We're back to the actual vehicle live feed, and
And if I
now
look
you
at
can see the
the
countdown
automatic
again.
launch sequence, the vehicle parameters being checked out, you see a lot of greens there. And the satellite being checked out sequentially. In fact, there are several hundreds of parameters which gets checked out through the onboard computer that resides in the launch vehicle. So today's weather here at the launch site has been very clear and favorable for the launch. As you are aware, for every launch, especially during the time of liftoff and while the launch vehicle travels through the atmosphere, which is during the initial 70 to 80 seconds of flight after liftoff, and it corresponds to an altitude around 25 to 30 kilometers. So by weather, what we really mean is the wind condition which exists on the ground and in the upper atmosphere. And as these wind conditions change during the time of the day and the month due to seasonal variations, accurate measurement of wind speed and direction becomes very important for every launch activity. So at the launch base, a very close monitoring of the wind and weather condition has been carried out during the launch campaign, and these activities in fact took the intense operations as we approached on the launch day. So the countdown is at minus 5 minutes 12 seconds. A view of the mission control center for you. So as I was mentioning you about the weather conditions for taking the wind measurements, there were
5 minutes and counting.
4 balloons that were released to take a measurement of the upper
MC
atmospheric
confirms
winds.
reception of radar's data.
In fact, the first balloon was released at 2 hours 45 minutes, second balloon at 2 hours 20 minutes, and the last balloon was released at 1 hour 40 minutes. And the reason for doing this staggered releasing of balloon is to allow them to reach the respective altitudes. Finally, the winds measured by this balloon over various altitude gets combined and synthesized to form a single wind profile from 0 to 21 kilometers. So minus 4 minutes 25 seconds for the launch. So based on the winds that were measured, a steering program was generated and it has been loaded in the onboard flight system at launch minus 45 minutes. A view of the mission control center. Chairman ISRO, Shri Kiran Kumar.
Mark minus 4 minutes and counting.
Minus 4 minutes for the launch now. So at T0, we will have the ignition of the solid core stage. Launch of the 4 solid strap-on boosters as well, which will get ignited on the ground. And this will be followed by the ignition of the remaining 2 strap-on boosters at 25 seconds into the flight. So at minus...
onboard computers in flight mode.
Minus 3 minutes, 25 seconds. And if you just go through the flight sequence, the first stage will take the vehicle to a height of around 56 kilometers and will impart a velocity of around 2.4 kilometers per second, and the separation of the first stage
minutes and counting
will take place in 110 seconds. So we are in the final 2 minutes for the launch, minus 2 minutes 49 seconds. So the page of the automatic launch sequence, as it is checking out the various health parameters, is looking all green. So minus 2 minutes 30 seconds.
phase 2 charging of PS2 accumulator started.
So countdown at minus 2 minutes now.
Mark minus 2 minutes and counting. phase 2 charging completed.
So another 1 minute 50 seconds to go before we have the ignition of the solid core stage and 4 solid strap-on motors. So minus 1 minute 30 seconds. So minus 1 minute 18 seconds. We are very close to less than a minute for the launch now. As I mentioned to you, the liftoff is at
Stand by for the
19
timer.
hours, which is 7 o'clock, with a,
Mark minus 1 minute.
so we are less than a minute now. We have a total launch.
55 seconds. All stops are on. Minus 50 seconds. All sequences are on.
So minus 50 seconds.
Minus 45 seconds. Minus 40 seconds.
So minus 40 seconds for launch.
35 seconds. Minus 30 seconds.
So we are in the last 30 seconds.
ignition key lock enabled.
Real-time programs activated. Minus 25 seconds. PS2, BSPPs are opened.
So minus
Minus
20
20
seconds.
seconds. Minus 15 seconds. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0, plus 1, plus 2, plus 3, plus 4, plus 5,
So
plus 6,
PSLV
plus
liftoff.
7,
Liftoff
plus
normal.
8, plus 9,
PSLV
plus 10
liftoff
seconds.
normal with the ignition of the solid core booster and the 4 solid strap-ons.
And we have liftoff.
Plus 20 seconds.
So 20 seconds.
Stage performance normal.
Plus 25 seconds.
Performance has been declared as normal.
Now relatively normal for the engine.
The air strap-on has been successfully ignited at 25 seconds.
So they just counted on plus 1, plus 2. As you could also notice, there is...
40 seconds into the
Stage
flight.
performance normal.
From very close by, you might notice this from other rocket launches as well, depending on how far away the camera is. Since cameras in rocket
So
launches
at
usually
70
have to
seconds
be
you will
very
have
far away,
the
you
separation of the
usually
ground lead
hear the
strap-ons,
rocket launch long after you see it. You could just
where
notice
the vehicle
this
altitude would be roughly
somewhere
around
at,
24
plus
kilometers.
15, you could
1
actually
minute.
hear the lift off, since the speed of sound took 15 seconds to reach the camera
So we're already
from the
60
rocket.
seconds. The performance of the first stage,
Ground lead
yes,
strap-on
ground lead
separated.
strap-on has been successfully separated at 70 seconds. The next important event will be the separation of the
change route
air
SCBT
lift
1.
strap-on at 92 seconds. The performance of the first stage has been normal.
Air lid strap-on
Air
separated.
lift strap-on has been successfully separated in 92 seconds. And as far as the altitude of the vehicle is concerned,
So the boosters are now gone,
it
and
is around
only the core stage is now
2.01
carrying the
kilometer per
rocket.
second. The first stage of the rocket 109
Separated.
seconds,
Second stage
and the second
ignited.
stage has been successfully ignited at 109
Plus
seconds.
2 minutes.
Now with the second stage burning, an interesting fact about the PSLV, actually
The
the,
nominal performance of the second stage
Second stage
performance is normal, and during the second stage of flight, the closed loop guidance has been algorithm has been initiated.
the second and third stage of the PSLV actually
Against
doesn't
when
use
to over
just
115
engine
kilometers, you
gimbal,
will have the
but a flexible nozzle, which is similar to engine gimbal, but instead of moving around the whole
160
engine,
seconds, velocity
you
2.
only elastically
Second stage
twist the nozzle to the same effect, which of course is much simpler in terms
6
of
kilometer per
engine
second,
plumbing.
and vehicle has traveled is around meters now. So 6 normal. Second.
What they're tracking the vehicle in minute?
Plus 4 minutes.
So 240 seconds into the flight, the velocity is around 4.33 kilometer per second. Altitude is 131 kilometers. The second stage cutoff is expected at 260 seconds when the vehicle would have been at an altitude of 134 kilometers.
Second stage engine shut off.
Second
Third
has been
stage
successfully separated at 263 seconds, and the third stage has been ignited at 264 seconds. So velocity of the
Third
vehicle,
stage performance normal.
the third stage performance is normal. The velocity is around 5 kilometers, and the vehicle has crossed a range of almost 658 kilometers. The third stage of the rocket, which is the PS3 stage, will burn for nearly 120 seconds. After its burnout, the vehicle will continue to progress
Third stage
further
performance normal.
before the fourth stage gets ignited after 230 seconds. So there will be a coasting time of around 230 seconds between the third stage burnout and the fourth stage. So we just heard the announcement, the PS3 performance is normal. So at 329 seconds,
Third stage performance normal.
third stage performance has been declared as nominal. So 348 seconds. As per the nominal timing, the PS3 burnout should happen at 385 seconds. The vehicle is at an altitude
Plus
of
6
around
minutes.
130.
Third stage performance normal.
So third stage performance normal. The vehicle is an altitude of around 138.5 kilometers. Another 15 seconds to go before we hear the announcement for the
Third stage action completed. Vehicle in coasting phase.
So third stage burnout, and the vehicle is burnt out, and the vehicle is going through the coasting phase right now. And as far as the ignition of the fourth stage is concerned, it should happen at 616 seconds. The time right now is 400 seconds, and the velocity is around 7 kilometer, an altitude of around 142 kilometers. So right now the vehicle is going through the coasting phase
Vehicle
of activities.
coasting normal.
So 400, another 200 seconds before we
Plus 7
have the
minutes.
ignition of the fourth stage. The view of the ground trace, where
What they're tracking in minute.
the mission control center here. The time versus altitude plot and the velocity plot that is depicted on the screen. This is the ground trace that is shown, where we have a very close match of the pre-flight prediction of the ground trace versus the flight conditions. And as far as the time versus altitude is concerned, a very close match with respect to the performance of the pre-flight. So we are going through the coasting. 90 seconds. As per the planned timing, the PS4 ignition should happen at 617 seconds when the vehicle would have reached an altitude of around 100. The PS4 region is concerned, the PS4 burning is for nearly 500 plus seconds, and after the PS4 ignited. The time right now is 575 seconds and the vehicle has reached a velocity of around 7.15 kilometer per second, the range of around 2,600 kilometers. The altitude is around 152 kilometers and the range is nearly 2,670 kilometers. So 625 seconds into the flight. The velocity is around 7.2. The vehicle has attained an altitude of 155 kilometers now. We're just awaiting the announcement from the range operation director to confirm of the performance on the fourth stage. So almost 200 seconds into the flight of the PS4 stage, so 694 seconds. The altitude is steadily rising to 163 kilometers and the velocity is 7 point. As far as the PS4 burnout is concerned, to reach an orbit of around 280 kilometers. Now we are at 7.5 kilometer per second velocity. Time is 727 seconds. So we're into the fourth stage flight. Velocity has reached around so the performance from the pre-flight prediction as of now, announcement from the range operation director. But if you look at the display plot of the time versus altitude and the velocity, we have the time instant of almost 800 seconds that has been reached. And the velocity is 7.7 kilometer per second. So right now the vehicle has attained an orbital velocity where we have a perigee of around 130 and apogee of around 1900 right now. Time is 834 seconds, 7.8 kilometer per second. Another 2 kilometer per second velocity is expected in the next 200-300 seconds burning of PS4 stage. So view of the ground trace. And as you can see on your screen, the time at 8:63, we have the perigee of 140 kilometers that is attained and an apogee of around 2,600 kilometers. The velocity that will be required to reach the final destined orbit will be 9.7 kilo.
We have acquired the signal.
So nearly
15 minutes.
900 seconds. Of just 8 kilometers per second right now, and altitude is around 232 kilometers. As far as the nominal altitude at the PS4 cutoff is
We
concerned,
have acquired the satellite signal.
it should be around 455 kilometers, and the time at that instant will be 1128 seconds. So another 200 seconds before we have the PS4 burnout. Now I'm waiting for the final clearance from the range operation director in terms of the performance and the remaining time. So 980 seconds. As far as the perigee and apogee is concerned, they are lower than the predefined number at this instant of time. So almost 1,000 seconds into the flight right now. Thousand 25 seconds. The velocity is around 8.3 kilometers per second.
Yak 1 and 2 tracking the vehicle in Minato.
So second stage, just awaiting the confirmation from the range operation director. So PS4 shutoff command has been issued at 1039 seconds, and as per the display screen on the flight events, been 6. So we are waiting for the announcement from the range operation director. As you can see on your screen, the perigee and apogee is around 167 by 6,554 kilometers. The time as is shown on your screen is 1185 seconds. So we'll come back to you once we have the formal announcement from the Range Operation Director. So Chairman is on your screen. Just waiting for the announcement at this juncture.
This is the Range Operations Director. During the flight, heat shield is not separated. Further analysis will be carried out subsequently.
So we just heard the announcement from the Range Operation Director that during
So hello everyone, this concludes the coverage of the PSLV-XL, PSLV-C39 launching the IRNSS 1H navigation satellite. Now the source this time was a bit buggy. The next few streams will be a lot smoother because they have a more reliable streaming source. Now my next live stream will be the Ariane 5 launching Intelsat 37E and BSat 4A on September 5th. And quite interestingly, on September 7th, a Falcon 9 will launch the X-37B experimental space plane. So yes, the US Air Force has contracted with SpaceX now instead of ULA. And of course, the X-37B has always been quite exciting, and it's also a reusable Falcon 9 that will land back at Cape Canaveral. Since the X-37B goes to a low Earth orbit and it is a relatively lightweight payload, it doesn't really take that much fuel, and the Falcon 9 can land back at Cape Canaveral instead of on a drone ship. Now in slightly other announcements, the ISS livestream is currently down, and if you've been on the internet lately or seen the news or actually live in the US, you will probably know that the US is right now being hit by a rather devastating hurricane, and actually NASA Johnson Space Center is also being hit by that. Now the center is pretty much in a bunker mode lockdown right now, so the people there are safe, and the The James Webb Space Telescope is also being kept safe, but they're operating on minimum staff. They're all overworked, and they're keeping up the essential functions to keep up mission control for the International Space Station at all. And they really have better things to do right now than take care of another live feed, and Johnson Space Center is where usually the live feeds from the ISS go through. So NASA Johnson basically receives the data from the ISS and then puts it through to the internet for other people to receive. So currently there are no live feeds from the ISS coming in. You can of course follow the NASA website or NASA's social media feeds or any other space news website to see further news on NASA Johnson Space Center. Now I'll show you one replay of the launch, and then I'll end this live stream again. You can always keep asking questions or discussing in the in the comments of any video. The ISS live stream is, as I said, currently not available. And now I'm going to show you one more replay of this launch. So this concludes today's live stream, and see you on September 5th or on any other video. And as always, thanks for watching.